Welcome back to Cybersecurity with Python and the Microbit. This is session 3 of 3. And here for the third time is a link to the slideshow in case you can use it. Chat and paste. And a reminder to those of you with a single screen, you can wiggle your mouse around, hit view in the upper right, then hit exit full screen and tile with your tile the Zoom meeting along with your Microbit Python editor. Actually, I should do that in plural. So today we're just going to finish off what's published for attacks and defenses, and that's malformed packets. Then we'll take a quick look at educational resources, a few fun cyberbot robot demos, additional resources. Well, you know what? I think that's probably better. Then we'll talk about upcoming workshops, how to purchase the Microbit and or Cyberbot robot, questions, answers, and any final wrap-up. So let's, actually, before we get started talking about malformed packets, let's make sure that everybody has their Microbits connected and ready to go. So display.show. Let's try that, see how it goes. I'm going to connect to Microbit 0 with this one. And then we'll copy that all over to this other screen. And then we'll call this Microbit B. And send that to the other Microbit. And last but not least, I should be pasting these into you. One moment. Well, might as well check to make sure that they're working properly. Yes, so we have Microbits A and B. So here come those scripts to make sure that yours are also connected and accepting scripts. So there's the A script, and you might just end up changing it to B more quickly than I could paste in the B script, but here it is anyway. And try to get your Microbits running if you're following along. And then let's continue with malformed packets, attacks, and defenses. So this is, I think I'm going to follow the link here, but then go back up one level. Okay, so this is the cover page to malformed packet attacks and defenses, and you'll hit continue to go into it. There's the cover page, and then going into it. The first one we do is a common thread, and that's our friend, the countdown timer. So this countdown timer has a malformed packet added to its code, or the option for sending a malformed packet. And the way that works is that this little stub has been added to the script where it sends, if -1 is entered to the script, what it sends when it's supposed to be putting an integer into the dictionary, it instead inserts a string there. And so we'll take a closer look at that in just a minute. And the thing that this will cause, though, is the receiver, since it's expecting digits, when it receives a string instead, it tries to convert that string to a number, and an exception occurs, and then the microbit becomes unresponsive until it's restarted, or until it has a new script loaded into it. So there is the sender script with the malicious, or no, yeah, that's the sender script with the malicious stub in it. And then here comes the currently vulnerable receiver script. All right, so let's put each of those into our microbits here. And this is one where we will need to have probably have these side by side, because we'll be looking at both their terminals. Okay, what I'm doing is I'm copying the script that I sent. Each script I sent, I should say. That didn't work out. Let's see here. So countdown sender. Okay, I finally got it. That was off screen there. Okay, and then countdown receiver. Alrighty, and then sending them both to the microbit and opening the serial monitor for both of them. We have enter countdown start. So if we do it normally, it works. We see that the dictionary is received, because that dictionary displaying feature is still there from the previous example. And notice that the dictionary, when it's functioning properly, has a digit in the start field. And then what the script does is it takes that text or it goes and finds the start value key, and then grabs its corresponding value. And that value has to be an integer. And if it isn't, the script will freeze. So let's see what this looks like when it receives a malformed packet. Again, if the value is set to -1, then the script substitutes a string for a number before sending out the dictionary. So -1 for the countdown start, and then message and enter. And now we can see that there was an exception that occurred. And if we look at the microbit, it's showing an error message. And after it's done showing an error message, it's going to jump into its default REPL mode here in the serial monitor, and it will not respond. So basically, if I try to send it another number, nothing happens, because this is off in REPL mode, which will accept things like print hello, and we can print hello, but there's not really any way to get it to restart. Or, well, I suppose you could potentially get it to remotely restart the program. I don't know what the statement is to restart the microbit to run the script. There might be one, but primarily what we'd have to do is go to the receiver microbit and press and release the reset button on the underside here. So it normally requires manual intervention, or you can just reload the script here. So now they're both ready to go again. And the script will certainly work again as long as I give it values that it expects. Not sure what happened to this connection. It's not responding. It looks like when I was handling the microbits, maybe I jiggled something loose on the connection here. So we're going to have to try unplugging these and plug them back in and reconnect and see how it goes. Okay, so we'll send the receiver to microbit whose serial number ends in 3 and some zeros. And then we'll connect the transmitter to the one that ends in a bunch of zeros. Okay, so now we're back up and running. And I'll just restart each of these just to get the full message in the serial terminal, because sometimes it doesn't display the whole thing on the first run after you physically connect it. And then, sure, it works just great again, but it took a physical reset of the receiver after sending it a string. And one thing I forgot to point out is that we can see here that the start field, or the start key value pair, which previously had a number in here, now has a string. And that is what leads to this type error exception that the microbit threw. So how can we fix that? Well, in the lessons, first of all, it talks about how to test this. And so it has pictures of what I just demonstrated. And so it has pictures of everything working just fine, and then pictures of what happens when the exception gets thrown, and then how that code works. And then it makes a suggestion. And notice that this is a try this section. So even though previously there was script that could be copied and pasted, the students absolutely have to put their hands on the keyboard to get this to work, because it's a screen capture. I suppose some students might know about extracting text from images, but it actually doesn't work that great with this extra stuff around it either. So it's certainly easier just to type this in. I did that ahead of time, and so bear with me while I open that one up. Okay, so this is going to be an update to the receiver, and I am looking for the let's see here. Countdown, search, countdown. Sorry about the delay. Let's see here. Here is countdown sender with malformed packet. And here is countdown receiver with exception handling. So we'll go ahead and drop that one onto the microbit Python editor. And so this has the changes, which I'm actually going to try to back up to the unmodified one. Hopefully that'll work. If I hit back, it doesn't work. Okay. I intended to show you the unmodified version. Basically, it did not have try, except, else, and finally. It just had all these parts of the script. Like this is the counting down part. And then this is the message after the countdown, and then an extra empty line before repeating the loop. And so what gets added, of course, is try out the code and find out if it has an exception or not. If it does have an exception, display a message about it. If it does not have an exception, go ahead and print the ending message as well. And then regardless of whether or not there's an exception, print an empty line. And so let's try this and see if it's hardened against this malformed packet cyber attack. Okay, so does it still work normally? Yes. Does it work, or does it not permanently crash when we give it the malformed packet? So it displays an exception and then is waiting. Well, does it really work? Yes, it is there. Okay, very good. So this is an example of it kind of emphasizes the importance of exception handling in what really amounts to a server application where we have a client that's asking to have a countdown performed, and then we have a server, and the server is what normally gets attacked, and like a web server being attacked. And so this is, no, it just gives an example of the importance of exception handling, as though frozen web pages aren't enough. All right, so that is the first example in exception handling. Now, this does go on. I'm gonna skip. I'll just talk about this briefly and skip past it. We do take a look at, gee, did that fix everything? Well, it turns out that no, it didn't, because another vulnerability here is that instead of sending instead of sending a malformed a dictionary with an unexpected value, the attacker can instead simply send something that's not even a dictionary. And the script and its exception handling didn't account for that. And so this guides the students through adding another stub that sends a non-dictionary, and then adding something to modifying the script to protect against also receiving a non-dictionary. Next up, students have told me they like this application, that it's kind of fun. So let's all run this one with both of our microbit modules. It's a single application that has the vulnerability and the malicious stub added to it. And let's go ahead and paste that into the chat. There you are. So go ahead and run this one on both microbit modules. And this one, there might be something that we see in the terminal in the serial monitor, but the main thing is to keep an eye on the microbit itself. So we'll go ahead and just send those into both microbits. And then what we can do is pick an image to send, and with the A button, and then actually transmit it with the B button. And so you can scroll through images, and when you pick one you want to send, you can hit the B button to send it from one microbit to the other. And I don't know if anybody noticed, but I've been intentionally avoiding the skull emoji, because when I send that, then that causes this microbit to an exception to occur in the receiver microbit, because there is a stub that when the skull is selected, it instead sends a malformed packet. And so here is where the here is the stub that changes the packet. It uses or it essentially sends something that cannot be converted back into an emoji. The rest of them, are obviously converted into an emoji using these strings up here. These are what get transmitted between one and the other, as you can see right here. And then when image.skull happened, a string that could not be converted was sent instead. And so how do we protect against this? Well, exception handling, exception handling, exception handling. So here again is the documentation for testing the script, just as in the previous one, with valid packets and then a malformed packet. And then here is the, well, this is a how it works narrative that accompanies most scripts. And then following the how it works narrative, there's a try this, which again is encouraging students to put their hands on the keyboard and modify the script. So this will take me a second again to find. Okay, here it is. And so we can put this into both editors. And then I'll go ahead and paste it to you. Okay, it looks like it didn't go into the left editor. So I'm going to paste it from the right and then paste it into you. So this is a solution that I typed in ahead of time. And it has too many characters. Okay. So what I can do is give you a link to a copy on my Google Drive. Okay, so share. Copy link, and now in the chat, there is a Google Drive link. And when you go to that, what you will see is kind of a gray-black screen with just a download button. So go ahead and download it. And then once it's downloaded, you can go ahead and use the open button in the microbit Python editor. And then if you're sorted by most recent file, it's going to be the topmost file in the Open Dialogues file browser. So like you can right click and select sort by and make sure you're in date modified and that it's descending so that the most recent one is at the top. And then it'll be nice and easy to find. And when we run these, Well, I'm not really sure. It seems like I have a ghost in the machine today. Um, and it really, I'm sure it does not have anything to do with the malformed packets per se, because both browsers, well, first of all, it wouldn't anyway, but both browsers seem to be kind of becoming unresponsive here. And I'm not really sure why that is. Let me try refreshing the browsers and see if that does anything. Send to microbit. Well, at least it's asking for a connection now. The button became completely unresponsive. Go ahead and send me a chat if you notice anything similar. But it's telling me to unplug and replug my microbit. So let's try that. This is not unlike what students will experience, although it's likely that the main culprit is that I've got two microbit editors connected to the same computer along with broadcasting with Zoom. That's not the usual stress that a single computer with a single microbit connected to it, like is in class, would happen. Okay. So let's see if that works now. All right, so now we're testing to see if the usual application works. And sure enough, the microbits are sending back and forth across their radios. But then if I go and select the skull on one of the microbits to send that malformed packet, it displays a frowny face several times, but then just goes back to the image it was previously displaying, which is essentially what how the exception handling code was set up to work. And so instead of being stopped in its tracks and no longer accepting any emoji, the microbit is hardened against such an attack, and so it continues to execute its application even when it gets a bad packet. It just tells you that something came in that it couldn't understand, and then goes back to its previous image. And there is also, though I'm going to skip it, an activity where students also add in encryption so that it's also sniff proof, or at least not as easy to sniff unless some of the brute force attack approaches are used. There is usually a cyberbot robot option at the end of any given, actually usually, forget I said usually, there is a cyberbot robot option at the end of any given attacks/defenses chapter. And so this one I think is kind of neat. So it's keyboard control, and so here we have basically a keyboard control option, again with a stub that sends a malformed packet. So I'll show you how this works, both with and without the malformed packet. Okay, open. Okay, so this is the controller from the page. I'll give you a link to the page, which has the sender and the receiver scripts, but I think they're too long to make it through the chat. And since you don't have a Cyberbot, it's not really that important anyhow, but just kind of watch along on this one. So here we are with the transmitter. Now I just need to open the receiver, and again, that's from the same page. So here is the receiver, the terminal controlled bot _ wireless. And if we open this up, I apologize for this. I should have maybe sorted them into subfolders. So here is the terminal bot controller. And okay, that's weird. I seem to have misplaced my my terminal controlled bot. So I'll show you the entire process for let's see here. Okay, so I'm going to cancel out of the open file thing. So for a Cyberbot robot, what you need to do is there's in the script, there's a from Cyberbot import star instead of from microbit import star. And this Cyberbot module is one that has to be added to a project. So I'm gonna grab the script here and paste it in as usual. But then we need to go and add the Cyberbot module to the project. See, it's complaining right now that it does not see the Cyberbot module in the project. So the project settings are in this lower left here, and you can see main.py, and that's this script, but there should be a Cyberbot module also showing. And back at learn.parallax.com, inside the Cyberbot Python version, the MakeCode version also requires a plugin, but in MakeCode, they're called extensions. And so this has a guide through adding the extension for the Cyberbot, and then Python has a guide for adding a module. So add modules to your microbit. And then since it's so common, we actually have just a quick shortcut where there's a Cyberbot template with Blink, and you can basically right click and select Save Link As. And then you've got that, and then you can open it up first of all, I'm going to copy the script. And then we can go ahead and open that template. And so what this does as is, let's see here. Okay, first of all, I want to see which one is going to be the bot controller by checking to find out which microbit has its light turned off, and it's this one. So now this one I need to put into a cyberbot. Okay, so here is a cyberbot. And I'll go ahead and take out the microbit that's in there. And I'll put this microbit in because we know that it's going to be the one receiving scripts from the editor that's on the right. And just to show you, this is a test script, kind of like the one that is the default when you open the microbit editor. There's one that displays a heart and then a hello message. And so with this, I can run it and then turn the power to the robot on, and we can see a little light flashing right here, and that tells us, yes, everything's in complete working order. In other words, the batteries are in the Cyberbot robot, the power has been turned on, the battery power is plugged in, and it doesn't actually matter after loading the script whether the USB cable is connected. So that's a nice quick test you can do. And then another thing I want to show you about that is simply that in these project settings, where previously it was just main.py, now we can also see cyberbot.py. And it has this protection so that nobody does anything to the script, because if they change it, they could get unexpected results. But you can also go and just modify the settings inside the editor, and then it will actually let you look at the code that's under the hood for allowing the microbit to control the Cyberbot robot. Okay, now I copied the keyboard controlled Cyberbot robot a little while back, and it's still on my clipboard, so I just pasted it in. And we'll go ahead and send that to the microbit that is plugged into the Cyberbot. And so I'd better move this microbit out of the way. And what I'll try doing is just sending the Cyberbot messages that will make it just creep forward slowly for a little while. Okay, so oh, that's the controlled bot. So we want the controller. Controlled bot. And there's the controller. Okay, so that's running. and it's telling us to enter a speed between negative 100 and 100. And so what's going to happen is when I enter those speeds, it'll be transmitted from here over the radio into here. And then this one will execute it so long as I have the power switch set to all the way to the right to the, there's a 0, 1, and 2 setting. And so I want to move it all the way to 2. That's what enables power to the cables that go to the motors. All right, so I'm going to give it kind of some slow speeds here. Let's say 30 for the left speed, and wheels have to turn opposite directions on the left and right of a vehicle. So we might want negative 30 over here, and then let's just have it go for a second. Oh, that's right. I set up the script so that it takes absolute forward. So basically, the left is supposed to be 30 and the right is supposed to be 30. And in earlier lessons, it's a little bit closer to the mechanics of it. But at this point, we've abstracted the script a little bit to allow for more intuitive operation. And so here we have it going straight forward, and then negative 30 and negative 30. Well, now it's going to curve because I typed negative 39. And so if we do that for a second, it'll curve backwards. They do tend to curve naturally, and students will go through an activity where they pick the correct numbers to straighten out the path if the robot does indeed display a tendency to curve. And let's see here. Okay, we got a few more minutes before the break. Now, what happens if I insert a malformed packet? And the stub for the malformed packet in this case is if milliseconds is less than 0. So if I try to go forward 30, again, at a speed of 30, but we say for negative 1 milliseconds, then what happens is the poor robot throws an exception and it starts turning in place and becomes unresponsive. So if I try to type in, for example, 0 and 0 to make it stop for 10 seconds, it does not hear that response. And this is where the robot becomes kind of an interesting thing for competitions where students need to meet a navigation goal, yet there are cyber attackers in their room attempting to take over or disable the robot. And so contests of that nature can end up really bringing home a lot of the relevance of these things, and also the relevance of electromechanical controls and how they can actually be vulnerable to cyber attacks just as computers and networks can. So if I send the microbit again, oh, I sent the, okay. So now, if I send this one to the microbit again, it wakes back up and will respond. But that's not necessarily practical if the contest rules state that you're not allowed to run back onto the contest field and manually restart your robot by reconnecting it to this USB cable for programming. So what's the solution again? It's going to be exception handling. And let's see here. So there is already a little bit of exception handling. But this is something that was built into the original script to, I believe, to just to make sure that it receives the right packet. So why did this even stop? I'm well, I'll start by loading the terminal controlled bot with exception handling. Okay, so let's see if we can open that up. Hopefully I'll find the version I saved this time. So here's a terminal bot controller. Okay. Let's just see what the solution is, and I'll type it in quickly. Okay, so for adding exception handling, and I do apologize for this bumpy presentation. Okay, so essentially what we're going to do is try everything that might throw an exception. And if an exception does occur, it stops the robot and then prints an exception that an exception occurs, and then it displays a flashing on-off SAD image for a little bit. So if I go back to the if I go back to this, it looks like this is the one where I was working on the solution. And so it is trying the whole thing. No, this is the controller. Okay. So if I go to the controlled version of the bot, there is no exception handling here. So what we can do is we can add the try statement right here. And then according to the solution that we looked at on the page, we can essentially try all the code that's responsible for controlling the robot. And then if there's an exception, we can basically discard what was received and instead just make the robot stop. And then flash a frowny face on and off. Display.show image.sad, and then sleep 100 display.clear and sleep 100. So let's see if that hardens the cyberbot and prevents prevents it from freezing up when it receives a malformed packet.
I think you've got a sleep 1000.
Oh, did I? Let's see. Okay, am I missing a sleep 1000, like maybe right here?
No, down further after you cleared.
Oh, yeah, that's going to make it take quite a painfully long time to, thank you, to do its blinking. So now if we send this to the microbit and go back, and I need the controller here. So this is the controlled bot still. Huh, let's see. So this is ready and waiting, and I need to find the one that terminal controlled bot wireless, try this. Yeah. Here it is. Okay. Okay, so now we have the controller, and we'll start with the same old test here. And it works fine. Now let's say we want to back up. But instead send that malformed packet of an incorrect negative time that it can't possibly run. And so hopefully it was visible. It flashed a few times, a frowny face. And then instead of being dead in the water, instead of, no longer responding, the idea is that now if we send it some valid commands, I didn't want it to turn in place for a second, but okay, so let's try again. -30, -30, and 1000. And so we still have our remote robot, and students who have hardened their script that way will not be able to be disabled by attackers on the field. And the tutorials also go into adding encryption again. And after how it works, there are some suggestions on how to add encryption immediately before sending and after receiving. And that pretty much completes the cyberbot section of the chapter, and also completes the chapter. So that's all I've got to say about the cybersecurity lessons. And after the break, what we will do is go ahead and talk about educational resources. So let's take that 7-minute break and resume at 5 past the hour. Okay, welcome back, everyone. We are now looking at some of the other things that can be done to expand cybersecurity with the microbit, as well as some of the other topics that are covered. And I think it's really worth mentioning. And so the first and foremost is the Cyberbot Robot series. Again, this has a make code version that also does include some cybersecurity lessons, some but not all of the cybersecurity lessons. And then, of course, there's the Python series, which has all of the cybersecurity lessons that we currently offer. So these are links to each one of those. And then here is an example of what the table of contents looks like. Looks like no, maybe that is all the projects. Let's take a look. Um, no, there's definitely a few more projects down there. So I'll loop back around to these projects too. And we'll just say for now that everything in the main lessons are for the stock Cyberbot robot kit. Everything that comes in the box is used in these lessons, but there's nothing extra required. The first three use class packs, which come with some extra line following and ultrasonic distance sensors. This is actually a rotating turret and TV remotes. And then the others include and then these four are designed for sold separately items that are kind of popular with the Cyberbot, or rather these three right here. And then this one is back to the stock SumoBot. And possibly when it's a little bit more developed, well, the reason it's here right now is because the plan is to extend the robot sumo. It currently applies to stock SumoBot or stock Cyberbot robots as a simple tilt-controlled SumoBot contest, but there are plans to also have optional additional equipment. So that's why we put it down here in projects. Anyhow, the Cyberbot robot has a co-processing microcontroller underneath its board that rides on top of the robot. And that's right here. And the microbit has an ongoing conversation with this. And then there's also some little sockets right here for connecting directly to the microbit. And then over here, the sensor circuits are typically added, sensor and indicator circuits. And the cool thing about having a robot as a way of learning code is that there's a physical response to a mechanically physical response to the code that is written that sometimes can get some of these concepts across in a way that sinks in better than in some cases if it's only done on the computer screen. The cause and effect relationship is something that is, well, it also causes some excitement, which makes it more memorable. At any rate, so here is an example, and like I mentioned, there in earlier lessons, straight ahead, this wheel has to turn counterclockwise, this wheel has to turn clockwise, and so that's why they are opposite directions. And we'll be talking about a lot more about that and things like that in the Cyberbot workshop that's coming up in early March. I believe, and correct me if I'm wrong on that, Ari, I believe that's still open for a few more days at least. And so if this looks like something you'd want to participate in, you could apply, and then we might see you at the next workshop. At any rate, so here is an example of a script that makes the robot go forward for 4 seconds and then turn right for just over a second and then stop. And as an example of how to reinforce coding principles, if you wanted to, for example, have the robot move in a square, well, great. We've got code for going forward and turning right, but Ari, it looks like he just pasted the sign up link. Thank you very much. into the chat. Anyway, so it would be possible to simply copy and paste the forward and turn right script a number of times to get it to form a square. But it's better to use the coding principles that were learned prior to in the prerequisites. We have the writing microbit programs, and that is where loops for repeating a certain number of times are introduced. And so here is an application of that. It reinforces that scripting concept, and it also works very nicely to have the robot repeat the same maneuver 4 times in order to draw that square. There are also sensors, and by the way, for each of these slides, I put in the make code block link to the chapter as well. So this is the make code block version. So if we go into this, and then after the instructions for building the, I had the contents collapsed here. So after the instructions for building the whiskers, there's a testing, the testing. Let's see where they put the script for testing this. There should be a script in here, and I'm not seeing it. Here it is. Okay, so basically, it describes the test first, saying, okay, if no whiskers are pressed, then nothing will display on the microbit. And then depending on which whisker you press, you can end up seeing a particular light on the microbit. And here they're both pressed. And then here is the make code version of the script that does that test. And then there is also the Python version. And when we go into this one, as you can see, it's the same basic instructions here. And the primary difference is that the script is in Python instead of in MakeCode block. And so that's the same test performed in either language. So I just wanted to point out that links to that all of the Cyberbot stuff has both MakeCode and Python versions of the lessons. And this example right here, there's some whiskers sticking out in front of the robot. And those sensors, once they cause electrical connections to occur from bumping into something, that causes electrical connections to occur on this prototyping area right here. The script finds out about that and then has the robot reverse direction and find a new way to go. Just hit the wall behind the box, and there it goes. Another set of lessons uses light sensors. And so in this one, we'll see the Cyberbot wandering along here. And then as it's got one trajectory, and then as a flashlight is shown in front of it, it sees that light and follows it. These lessons have lots of good they're yet another way to reinforce basic scripting principles, but they also include lessons about electricity and electronics, and actual sensor measurements, and an appreciation of how those things work in robotics. Now, sometimes the whisker contact switches to bump into things leave something to be desired. So there are also infrared sensors inside the kit that have infrared flashlights and then infrared eyes. And the Cyberbot with those and the correct script is able to detect objects without actually bumping into them, although it looks like it responds in the same way as though it had bumped into an object. Now, when you get a classroom full of Cyberbot robots, that little keyboard control example that I showed you earlier becomes a little bit more dramatic. As speeds are entered, if all the Cyberbot robots are on the same channel, group, address, etc., well, then one computer can control the whole classroom's Cyberbots, and it makes a pretty impressive display. Let's see here. And then this is just a little slide about an exception lesson, because even without the intent of a malformed packet, if the user types in text where they should have typed in a value, it will cause the Cyberbot robot to stop in its tracks. Tilt radio control is pretty nifty. And so here is the tilt control application. This microbit is roughly, it tries to create a pointer that points downward. So whatever direction the person holding the microbit is tilting it, this is pointing approximately the direction that a ball bearing would roll off, or a marble would roll off the top of the microbit if it was set on there and the microbit is tilted. For troubleshooting purposes, that's also displayed on the microbit that's on the Cyberbot robot. And so the user can tilt it away from them, and the Cyberbot will go forward toward them. Cyberbot will go in reverse. And then they can also tilt it forward or away from them and then tilt it to the left, and the Cyberbot will turn to the left or to the right, depending on how they, whether they tilt it to the left or to the right. So here's what that looks like. And the current sumo wrestling application uses this approach for remote controlled sumo wrestling, which is good in two respects. One, there's lots of classroom excitement about this kind of application usually, especially when there's a sumo ring introduced. And then a second one is that it gives students a chance to practice so that they can come up with strategies for when they're doing autonomous robot sumo. It'll give them a better feel for how to write the scripts. And I guess I got ahead of myself here, because these are the links. And essentially, this page just basically, or this chapter currently just talks about, okay, go to the tilt control chapter, get them both running. Here's the design for a sumo ring, and here's the rules for SumoBot competitions, and have fun. And then we plan to very shortly add some autonomous sumo wrestling to this as well. Then tilt control can also be, it gets a little more fun when we add a gripper into it. And the difference between just simple tilt control and the gripper is that now these A and B buttons are used to control whether to open or close the gripper. And it also demonstrates how to extend a dictionary to contain more data to expand a robot's features. So here we are, that's the closer button closed it and the further button opened it. That's the closer button to close the gripper. And then it's being tilt controlled to bring us the orange cylinder and let go of it. Another example of, and so again, this is from projects. This is a sold separately item, whereas the other things I've demonstrated so far are all were all for the stock Cyberbot. I mentioned earlier that the Cyberbot has a natural tendency to lilt to the left or right, and one of the activities in the early navigation lessons shows students how to correct the path to go straight. Well, there's also a different servo motor that can be used to replace the stock one. And that one has a built-in sensor called an encoder that will allow it to know the angle of the wheel at any instant. And so keep an eye on the little marker on the wheel as it does its little navigation routine here. So it goes forward and stops, and see how it settles so that the marker is still pointing down. It was programmed to do a full circle. And even after all this navigation, there's no error. And then it goes back to its original position. So this allows scripts to tell the Cyberbot to go to particular positions. It's not a there's an interesting reality that comes with this solution, because the students will still find that there is some error simply in wheel slip. And then there's also very small windows of, what constitutes the wheel being in the correct position. And if there's even a little bit of variation in that window, but then it travels a long distance, the difference in angle after, say, turning, but not turning exactly as expected, will still result in some propagated error. So it's a great servo motor, but it's not the final answer to accuracy. Usually mounting sensors, setting up some kind of sensor system on your robot to also correct things ends up finishing the job. And then this is just tilt control with those feedback 360 servos. Oh, actually, yeah, this is kind of fun. Let's look at that. Let's see if I can find the video for this. Okay, I'm not seeing the video I was looking for. There is a video where it goes and picks something up and puts it on a target. But I don't see that at the moment. But it is an interesting application of having a gripper and the feedback 360 servos that know their angular position as the script runs. Another series that is kind of nice is the What's a Microcontroller series. This is currently only in Python, and this introduces the basics of electronics for electricity and electronics classes. And so it shows things like how to essentially how breadboards work and how circuits are built on them. And I think this is this is where we're setting up the measurement system. So the microbit actually can take electrical measurements. And in this case, it's a continuity tester, and it's testing to see if there is an electrical connection. And so there's a continuity tester script, and then there's some tests where the students will put the wires into the same row of 5 and see that they hear that it's connected, and then if they're in a different row of 5 sockets, they'll hear that it's not connected. And so that's one example of something that's done, but there's quite a bit of measurement options. So in the electrical measurements section, for example, students will start by building a light circuit, and then they'll test to measure the various voltage drops across the circuit. And so here is an example, and I'll just run this one in a new screen. Uh-oh, have to fix that link. That looks like another casualty of the migration to a different platform. So in what this is showing is several things. First off, it's showing what the schematic looks like as the various measurements are taken. And then each time the probes move, you can see that the schematic is updated. Each time the probes are put in different positions, you can also see that the voltage measurement changes. The microbit is actually sending its measurements to a web browser that connects to it, much as the microbit Python editor does. And last but not least, this is demonstrating Kirchhoff's voltage law, which states that the sum of voltages in a series circuit, like there's the total voltage across the circuit, and if you add up the voltages taken across both components in the circuit, they add up to the total voltage across the circuit. And we go through Kirchhoff's law, Ohm's law, all that good stuff. There is quite a lot more, and by the time we get to servo control, for example, students are using the microbit to measure the signal activity that results in controlling in a servo being able to control its position. And so this time the microbit is sending data to a virtual oscilloscope that is in a web browser. And these are all free resources. And it's kind of neat that the microbit can function as the measuring tool for an oscilloscope. The oscilloscope, by the way, is at cyberscope.parallax.com. I'll paste that into the chat. And instead of setting up a whole measurement and stuff, I'll just go ahead and show you a little video that that shows the measurements as they're being taken. It's a little demo mode where it's just plotting, but it shows that we have an oscilloscope here that is plotting two different electrical signals, and the oscilloscope's features can be changed just like a real physical oscilloscope that's on an electronics workbench in, say, an electronics lab in a factory or school. And here, a feature called a trigger was used, and then these are voltmeter, ammeter, and ohm meter measurements that are also available with the system. So that's kind of a neat thing for the microbit to be used to introduce electricity and electronics. Looks like I forgot to add in the AI slide. So if we go to learn.parallax.com, artificial intelligence, give you that link, paste. This set of lessons focuses mainly on chatbots. Students can get access to, say, Bing Copilot to try out these lessons. They are frozen in time because they are written with the understanding that AI is going to rapidly improve. And so, so students will take a look at, okay, well, here's how an AI can write a script for you. And it goes through asking ChatGPT in this case to write a script. And then it chronicles the back and forth between a user and ChatGPT as it's being guided through writing a script. This beating heart script is much different from the one on Make It Code It, and it's certainly not as concise or easy to read. And so, so the suggestion is made to ChatGPT to use the microbit's built-in image.heart and image.heart small. And sure enough, ChatGPT is able to update the script, and these are tested as part of the activities, and the students can see how it can do things correctly. They also see, for example, how a chatbot can really not do things right and can have a very difficult time being guided to get the program to work right. So the second half of this chapter is generating what's called a tilt compass. It's kind of a fun little app. So let's do the existing tilt compass, the one before ChatGPT is guided through it. You can try this one on your microbit. Paste. Okay, so here is my existing tilt compass, and as I mentioned with the tilt controlled Cyberbot earlier, it does its best to point the direction that a marble on top of the microbit would roll downward at depending on how it's tilted. So try that one out. It's a lot of fun. At any rate, the chatbot had a tough time with this. And so this chronicles the whole back and forth between the chat bot and emphasizes essentially, hey, AI can do things for you, but what happens when it runs into a wall? It needs expert guidance. Well, are you going to just use a chatbot to answer everything for you and then become helpless when the problem gets too hard? Or are you going to be the kind of student who works hard to learn the topic so that you can be the expert on it that guides the artificial intelligence to greater answers? And then we also do go into the cybersecurity aspect of it in AI. And what this covers is essentially, hey, did you know that both cyber attackers and cyber defenders currently rely on AI and will increasingly rely on AI to mount both their attacks and their defenses against those attacks. And the example that this one walks the student through is one where essentially a backdoor is created for sending a script that the microbit executes that makes it unresponsive, and then it also asks for advice on how to harden the script against that kind of takeover. And so here we are at the end with some advice on how to make it more difficult to take over the microbit, even if it does have some kind of maintenance portal where a script can be inserted. And also how AI can essentially be tricked to write a malicious script because it can't tell the difference between a maintenance portal and a backdoor. I mentioned this on day one. Mentioning it again, we have student lessons here at learn.parallax.com, and then teacher resources at learn.parallax.com/educators. And so here we are at the educators page. And before I log in, I'll show you what it looks like here at, say, cybersecurity with Python and the microbit. Notice that things that a student wouldn't necessarily try real hard to get to are available, like the Cyberscope virtual multimeter and oscilloscope, and the YouTube a YouTube playlist for the microbit, and these are just general resources, the tutorial series. And then the educator resources you're not allowed to get to if you're just coming here without being a teacher who has been vetted by Parallax and allowed into the system, which all of you have. So what I'm going to do next is log into the Learn site. And to do that, you can go to Educators and then select Login, although you also had the direct link on Friday, or I'm sorry, for the homework, I sent out the direct link to learn.parallax.com/login. And I am currently off screen logging into the Learn site. It takes me a little bit longer as I'm using a two-step process. I'll be back on screen in a minute, logged in. Okay, so once you log in, it's going to take you to kind of a, a user page. And after that, you can go back to educators. And when you go into, say, cybersecurity with Python and the microbit, now you have a lot, instead of a picture of a lock and a message saying you have to be a teacher and you can go to learn.parallax, or you can email education@parallax.com to sign up. This instead now shows us a link to all the assessment materials. And so, for example, if we were to download, say, encryption intro, then we can go ahead and unzip that. Extract all is somewhere down here. There it is. And we usually make a PDF and an RTF so that it can be opened in either a PDF reader or web browser, or in, say, Microsoft Office. And so here is the web browser version. And this particular example is a worksheet. And then there are solutions that you'd want to not print at the end for you. So that is an example of the resources you can come to learn.parallax.com/educators, sign in, and harvest. A reminder about the Make It Code It site that I mentioned on the first day. Again, that's a great warm-up. For other resources, cyber.org has some interesting cybersecurity material with the microbit. It's for teachers in the United States only. It's for it's for K-12 teachers in the United States only. You can sign up, and if you provide your district email address, then they usually just send you, let you sign up as we do, because we just check on the district roster and then confirm that you're a teacher and send you the login credentials. This is not exactly current, but if you go and look for cyber literacy after signing up for the cyberbot, or pardon me, for cyber.org, you will, if you go and look for cyber literacy, there's first of all, there's coding fundamentals, which has some material for the microbit in coding basics and a couple of really simple cybersecurity examples. And then cyber literacy has some more involved examples, including scripts that do different levels of encryption, like there's an Enigma cipher and an AES 128 cipher that is a module that is added to the microbit project. That's for microbit 2.0 only, by the way, because it takes a fair bit of memory to do the AES encryption. And then there's other stuff like network, using the microbit to emulate network devices, and then a number of additional attacks and attack and defense examples. As far as obtaining a microbit, Parallax has a number of microbit products, and we are a microbit channel partner. And so I have included a link here to Parallax, and then you can go to Shop and then select microbit. And then you could focus on, for example, microbit kits. Okay. Yeah, my web browser has had a ghost in its machine all day. Let's see here. Maybe on the next slide, I'll have a direct link. Here we go. So this is parallax.com/category, slash product category slash microbit. And we'll paste that into the chat. There you go. So this is all things microbit here, and maybe hopefully it'll let me. No, it still won't let me click stuff. Regardless, if you go through here, here is, for example, the Cyberbot robot, the full kit. We also have the Cyberbot robot class pack. Now, this is the one that has, let's see, it has a total of 12 robot sets, but it also has additional sensors, those line following sensors, and the ultrasonic sensor that rotates on a turret, TV remotes. It also has battery chargers and rechargeable batteries. So it's kind of a nice, it's a nice kit for the Cyberbot robot. There's also just individual microbits. So for example, if we go back to, looks like I lost my place again. Let's try. Here we go. Looking through here a little further, this is the club bundle. It's a 10-pack of the 2 Go bundles that we sent each of you. I'd also like to point out, if you already have a class full of microbits and just want to expand into robotics, there is a no microbit version of the Cyberbot robot where you can simply plug in your microbits after putting the robots together. There's also a conversion kit for folks who have older Parallax robots, say with the basic stamp, the Arduino, or propeller. The QTI line follower and the ping on a turret are sold separately. And here is the Microbit Go bundle. So this is the one that we sent you for this workshop. And so here it is with its battery pack for like the tilt control application, a smaller version of the programming cable than you would find with Cyberbot. Cyberbot has a much longer USB cable than, of course, the microbit itself. So that's all at parallax.com/product category /product-category/microbit. And again, I pasted that into the chat. For upcoming workshops, I should mention, and already did mention, but I want to mention again, that we have the Cyberbot robot with the microbit coming up on March 3rd, 5th, and 7th. Another thing is, if we go to events, and if you scroll all the way to the bottom, you will see on-demand workshops. And what we're doing right now is we're retooling our on-demand workshops to work in lockstep with our new website. And so we removed the previous incarnations of all of them except for Arduino, which didn't need to be changed. And so for the microbit for beginners, that was a workshop that we just ran, and so now that's up. And after today, hopefully sometime next week, we will have the on-demand version of the Cybersecurity with Python and the Microbit workshop posted. And then after we finish with the Cyberbot robot with the Microbit workshop in early March, we'll go ahead and add that over here too. And so this is a good site to go to. I'll go ahead and paste the link in here. You can follow any of these links to see more information about the workshops. There is also a past events page where you can see workshops and other events that Parallax has done. Since we are retooling for a new website, I recommend staying in the Educators Workshops area. And then if you're looking for something, you will see an increasing number of on-demand workshops as we redo each of our workshops for the current website. For contacting Parallax, here's everything you need. education@parallax.com is the best email to use. This will go to me, Ari, and a couple of other people, and basically whoever can give you the best answer will be the one to take your email and answer. So if you need tech support, if you need help placing a purchase order, regardless of anything you need, if it's education related, just email education and we will get back to you promptly. And the best person to get back to you will be the one who does. You can also, if you want to make any purchases, simply call our sales department or email them. We have a forum and a Facebook page, and then there's a Microbit page down here too that has some interesting projects in it. Well, I'd like to thank you all for having come to the workshop today, and we'll look forward to seeing you at another workshop. Also, have a great weekend.